In the world of AI, the mantra is always bigger is better, right? More data, more power, more parameters. But what if that's not the whole story? What if, for some of the hardest problems out there, the real solution isn't about getting bigger, but about getting smarter? Well, let's get into it, because there's this tiny new model that's basically flipping the script on, well, everything. So here's what we're going to do. First, we'll see where these massive AIs totally drop the ball. Then we'll check out a super complicated first try to solve the problem. After that, we meet the hero of our story, this simple, elegant solution. We'll even get into how it thinks. And then the big finale, the results that show how less can actually be more. Okay, first up, let's talk about the big guys, the titans of AI, the large language models. Because it turns out, they have a pretty surprising weak spot. And this really is the big question, isn't it? We just assume that if you have an AI with billions or even trillions of parameters, it can do anything. But when you get down to pure structured logic, does that assumption still hold up? Well, the truth is, not really. I mean, don't get me wrong. These huge models are amazing at language, writing poetry, you name it. But when you throw a really hard puzzle at them, one that needs strict step-by-step thinking, they just hit a wall. We're talking about things like super complex mazes or those nightmare-level Sudoku puzzles. And this isn't just about games, you know? This is about the kind of thinking you need for real-world stuff like logistics or scientific research. And wow, just look at these numbers. And no, that is not a typo. 0%. We're talking about models with hundreds of billions of parameters, some of the most powerful AIs on the planet, and they got a big fat 0. They aren't even getting close. They're just failing. And it's this total failure that really blew the doors open for a completely different approach. Okay, so researchers saw this problem and they knew they had to do something. Their first crack at it was, well, it was smart, for sure, but simple? Not even close. This first attempt was called the Hierarchical Reasoning Model, or HRM. And HRM was a pretty big deal. It was the first thing to really show that maybe smaller, more focused models were the answer. It proved the concept could work. But the way it was built, oh man, it was just super complicated. I mean, check this out. It had two separate networks running at different speeds. The whole thing was justified with these really dense arguments about how our brains work. And the math behind its training was, let's just say you needed a PhD to get it. Plus, it was still pretty beefy at 27 million parameters. So yeah, it worked better, but it was a real beast. And that complexity is exactly what made someone think there has to be a simpler way. So after dealing with that monster of a model, researchers basically took a step back and asked a brilliant question. What if we made it simpler? Like way simpler? Could we actually get better results? The answer was a huge yes, and it's called the Tiny Recursive Model, or TRM. And this slide just says it all, doesn't it? On one hand, you've got HRM, complicated, two networks, 27 million parameters. On the other, TRM, super simple. One tiny network and only 7 million parameters. That's almost 4 times smaller. It just tosses all the complex theory out the window for something that feels, well, just natural. So what exactly is this TRM thing? At its heart, it's just a really elegant idea. You have one tiny little network, it takes a look at a problem, makes a guess, and then it just loops back on itself to think about its own guess and make it better, over and over and over. It's all about this cycle of refinement. All right, so this is the million-dollar question, or maybe the 7 million parameter question. How does this tiny thing outthink a monster AI that's literally thousands of times bigger? The secret sauce is all in how it thinks, inside this loop. It really boils down to two big ideas working in perfect harmony. The first is called recursive reasoning, and the second is deep superposition. Let's unpack what those actually mean in plain English. Okay, first up, recursive reasoning. That's just a fancy way of saying the thought loop. Think about how you solve a puzzle, like a Sudoku, right? You put a number in a box, then you look at the row and the column and think, does that work? If not, you erase it and try something else. That's exactly what TRM is doing. It makes a move, checks its own work, makes it a little better, and then does the whole thing again. It just keeps getting smarter with every single cycle. Then there's the second piece of the puzzle, deep supervision. And this part is absolutely key. See, most AI models, they only get judged on the final answer. It's either right or wrong, that's it. But TRM is different. It's trained to get better at every single step in that thought loop. The analogy is perfect. It's like having a math teacher who doesn't just grade your final answer, but who checks every single line of your work. That way, you don't just learn the answer, you learn the right way to get there. So when you actually lay it out, the whole process is super intuitive. Step 1, make a guess. Any guess. Step 2, think about that guess. Step 3, make it a little better. And step 4, just repeat. Do it again and again. With every loop, it gets just a little bit closer to the right answer. It's simple, it's powerful, and man, is it effective. All right, now for my favorite part. We've talked a lot of theory, but does this little looping model actually deliver the goods? The results, well, they're pretty spectacular. First, let's just let this number sink in. 7 million parameters. I mean, in a world where we casually throw around the words billions and trillions when talking about AI, 7 million sounds like nothing. It's almost funny how small it is. But as you're about to see, you should not underestimate it. And here it is. The proof is in the pudding. On these ridiculously hard Sudoku puzzles, the old, complicated HRM model got about 55% right, which is, okay, not bad. But our tiny little TRM, it scored a whopping 87.4%. That is a huge jump in accuracy from a model that is way, way smaller. So what is going on here? How on earth is smaller beating bigger? Well, there's a really interesting quote from the research paper that gives us the main clue. The researchers think it's all about avoiding something called overfitting. Here's an easy way to think about it. If you give a giant AI a bunch of puzzles, it might just memorize the answers or the patterns without ever learning the logic behind them. That's overfitting. But TRM, it's just too small to memorize everything. It doesn't have the space. So it's forced to learn the actual step-by-step process. And that's what makes it so much better. It's the ultimate proof that a clever, elegant design can beat brute force any day of the week. And that really leaves us with a mind-bending question, doesn't it? If this whole less is more idea works so incredibly well for these kinds of puzzles, where else could it work? What other huge problems in science or engineering are out there just waiting for a tiny, smart AI to come along and think its way through them? If this stuff gets you as excited as it gets me and you want to learn more, you should definitely check out the team's Medium publication. It's called AGI is Living Intelligence. It's just a fantastic reminder that sometimes, the very biggest ideas come in the smallest packages.